type of reasoning. And the reasoning we're gonna go over today, from the 10 years I've been teaching and also the years that I was a student. People usually struggle with this type of reasoning. But I think it's because you didn't learn or you may not have learned in earlier school, a different method of solving these types of questions that I learned when I was like in 4th grade. Go ahead, listen. Cross cancel.
Cross cancel where y.
Right. So I learned this idea when I was in 4th or 5th grade, like pretty young, and it stuck with me. And then when I learned it in chemistry, which is what you're about to learn today, I was like, oh yeah, I've been doing. That's how I solve multiplying fractions. So it was super easy. But I feel like for most students in my 5th period yesterday, one student out of 30 raised their hand that they were knowledgeable about cross canceling. So I'm just going to show you the alternative method. So you could have solved this a different way instead of multiplying across. You could have done this. And this is how I learned when I was a kid how to do this. You would look across and you would see 4 goes into 4 and 4 goes into 8. How many times does 4 go into 4? 1, so you choose the 1. And how many times does 4 go into 8? And you change the 2. And the x's are the same top and bottom, so you would cancel them. If you have the same thing on the top and the bottom. We call that cross cancel. And then over here we have 5 and 15. 5 goes into 5 how many times? 1. 5 goes into 15 how many times? 3. And then you just multiply those left. 1 times 3 is 3. 1 times 2 is 2, and that's the answer. 3 over 2. And so you don't have to multiply across top and bottom if you understand that technique. Your numbers are always a lot smaller as a result. And you don't have to find the greatest common factor and all of that stuff to get rid of because you're getting rid of it from the beginning. And so it's just a strategy. You don't have to know this to be successful, but you have to know this to be successful today. That if you have any letters or variables or numbers that are the same on the top and the bottom of a fraction, they cancel out and become 1. Not 0, they become 1. So given that, we're now going to go back to how this applies in science. Where do we use this in science? And then next class we'll get back into atoms and molecules and all that stuff. So back in the beginning of the year, so this lesson, like I said, this is something I could have taught you in September, but I chose to hold off until now because the skill we're going to use when we get back into the chemistry component. Units of measurement. We went over this in the beginning of the year. We went over that when we're measuring mass, we should be using grams to do so. And when we're measuring volume, you need to know that the base unit is liters, or for international study. So I'm going to write Cambridge/international study. It would be meters cubed. You're going to start to see when we look at units, Cambridge does their units a little bit different than America. I am under the impression that some of you may move on to the AICE course, and some of you may not. But you may take science in college. And so what I try to do with this class is teach you both ways, meaning that I know that in America we're going to use liters. Like if you move on to take more chemistry classes in America, you're going to use liters. But if we were to study further Cambridge study, we actually use meters cubed. So you'll notice that I'm presenting you with both, so you're aware. And I'll explain why a little bit later. But these base units are what we're going to be using as we get through metric system. Why is meters cubed the same thing as liters? It goes back to volume being length times width times height. So if you take meters times meters times meters, which is the base unit of length is meters, you would get meters cubed. That's why Cambridge uses it instead of liters, which is what we use in America. And all of our devices will measure in milliliters. You may have noticed in a lab actually recently, you were given milliliters, but then something asked you about centimeters cubed, and I told you, if you asked me, I said, well, they're the same thing. It's that same idea, that Cambridge will be using their units in length cubed for volume, because volume is length times width times height. So these are units of measurement you need to know. Grams, liters, meters. We call these base units. In every other country besides America, we use metric system exclusively, and in science communication, we use metric exclusively. Only in, I think it's America and Britain, somebody else may know somewhere else where they use it, we use the English units of measurement, which is like quarts and pints and gallons. Those are called the English pounds. Those are the English units of measurement. And so the reason why we use metric conversions is in science and internationally is because if you understand how to use metric conversions, they're very simple to convert between small units and large units. So you're going to notice that this paper here that I handed out has this slide right here. And so on the top of this paper, you're going to write unit 6, lesson 1. So you know where this belongs. And on this side of the handout, you're going to write memorize. Metric system has to be memorized. That will not be given to you on a quiz, on a test. You need to know metric system off the top of your head. Some of you may already know some metric system off the top of your head, especially if you took physical science. If you didn't, it's okay. I'm going to teach you a quick and easy way to be able to go through metric system. And so this is actually not even close to all of metric system. But this is what Cambridge requires you to know, so that's what I stick with in terms of what you have to memorize. Yes. If you want to. But I'm going to give you a method to do it simply. So there's an acronym here to help you memorize all of your different modifying prefixes. And so it's King Henry, and this is one you might have learned back in middle school. King Henry died unusually drinking chocolate milk. Now, this gives you the prefix, the first letter gives you the prefix that you're looking for. K stands for kilo, H stands for hecto. DA is confusing, the di being deca. Unit is your base unit, whether it's meters, liters, or grams. The second D is deci, which is little d. Centi is chocolate, and milli is the last part. And so these are in order from the largest unit to the smallest unit. So that's why we memorize it as an acronym, because it goes from largest unit to smallest unit. And so the really powerful tool you're going to have is if you memorize these prefixes in this order, you'll actually be able to solve any metric conversion question simply by moving your decimal to the left or to the right, because this operates off of place value, meaning that each of these units are 10 times off from each other. And you'll see that here, where this is 1,000 units, 100 units, 10, 1, and then it goes back like that. And so they're all off by 10. So yes, the maybe bad news is that you have to memorize all of metric system that's here. But the good news is that I can give you a simple way to do it. Before I show you, though, a couple of things you need to know. First question I usually get from students is, how do we know we're in the base unit when we're looking at prefixes and we're looking at letters? We're going to be using abbreviations most of the time. I'm not going to write out full words. So if I see one letter in my abbreviation, this means I'm in the base unit. So for example, if I see the letter M, that means I'm in meters. If I see two letters, so let's say I see CM, what does this mean? The first of those two letters is the prefix, and the second of those two letters is the base unit it's modifying. So C would be centi, right? And then M would be the meters, the base unit. So if I see two letters, this means that I have some kind of prefix. The first letter is the prefix. And so just real quick, if I then see KL, what does that mean I have? Kilo, liter. If I see just L, what does that mean I have? Liters. So that's one of the areas in the past where I see students get confused, because because every question you're gonna be presented pretty much is with abbreviations, not with the full word. So you have to know how to work with the abbreviations. If you have one letter, that means you're in the base unit. If you see two letters, that means you are in a prefix somewhere in here. So that's the one thing. The other thing is, how can you tell the difference between DECA and DESI? That's the other source of confusion here. I got a couple of notes to say about this. The first one is DECA, the actual two-letter abbreviation for DECA. They have to do two letters because they already have D for DESI. Is DA, so you can just memorize it as DAD, D-A-D, DAD, like that. I was trying to come up with something yesterday, felt like I got booted off the stage. But by the way, I'm teaching A days first for a little while, for a couple weeks, and then we're switching back to B days going first because I'll be out of the building, but not on a B day, on an A day for something. So A days are getting the lessons first right now. But anyways, I came up with something, and you guys can move me off the stage too, but maybe it'll stick, we'll see. Instead of memorizing King Henry died unusually drinking chocolate milk, you could do King Henry dabbed unusually drinking chocolate milk, you know, like dabbed. You know, dabbed. Whatever. Anyways, so the idea is that if we incorporate that, then it would be, you would know it's DECA. Yes.
My old
Danced. Okay. Danced unusually. What? It works. It works. The other thing I'm going to say is that Cambridge actually never uses. I've looked at over 200 old Cambridge exams. They never use DECA in questions, and they never use hecto in questions, like ever. But why should you still include it in your little chart that I'm going to show you? Because each movement of one is a movement of one decimal place. So that's why they still need to be included, even though they would never be asked by Cambridge. Just to help you with your movement. It's not relevant. Like, I've never seen anybody describe a hecta anything. Hecta either. All right, so here we go, practice questions. How do we utilize the chart that I've given you to help with solving questions that are metric conversion? So metric system conversions. Go ahead and write exactly what I write. I'm going to give you a strategy to help you with solving these questions. That will not require the use of the math we're going to do in the later part of this class. So the first step is to write a number line. Create a number line. And once you visualize this, you may be able to do it in your head, but for now, write it out. Create a number line. And so go like this. Instead of putting numbers on your number line, put the one-letter abbreviations of each of your prefixes in order. So it's King Henry, I like dance, that's good. King Henry danced unusually drinking chocolate milk because it's less lethal. King Henry danced unusually drinking chocolate milk.
Drinking chloride milk.
Oh no, that makes that. If it was chlorine.
Yeah.
Oh.
King Henry died unusually drinking chloride milk.
You can memorize that one. What you all decide to memorize, feel free. Whatever works. So create a number line like this. And the next thing you're going to do is underline in your question, what are you given and what are you asked for? You're given meters in this question, and what are you being asked for? So this is your start, and you're being asked for millimeters. And so identify on your number line where those are. So meters is what on your number line? Nope. It's one letter. So that's why I said it's one letter. It has to be the U. So this is where we're starting because meters is a base unit. So I'm going to do it in a different color just to say that that's where I'm starting. Where am I ending when I want to do this conversion? I want to go from meters to millimeters.
You're gonna go to that one.
Going here, right? So this would be my end. And so now, here's the really cool idea. If the light bulb clicks and you get this, it's going to be super easy to do all metric conversions. how many spots away is M from you?
3.
3 to which direction?
Goes
Three
Yeah,
to
right.
the right,
Right.
right? So that's how you would move your decimal in your number as well. 3 to the right. So that means you would go 1, 2, 3. If there's no numbers there, what do you have to add in?
0.
And so it's 100,000 milliliters. It's the same as 100 meters, and that's awesome. We're gonna try this again. So for the second one, I'm gonna create another number line.
That's simple.
This is the simplest type of conversion you can get. And if, like I said, it sticks, you'll be able to do a lot of your conversions this way that are not in the English system. And for Cambridge, remember, they do metric pretty much exclusively. So this is a very powerful tool. All right, the next one, B. Oh no, 2.50 times 10 to the negative 4. What is that? That's in scientific notation. How would I move my decimal over for that?
4 to the
You should probably start by doing that, so you know what your actual standard form number is. So negative 4 means move 4 to the left. So that means that this would be 1, 2, 3, 4. So far, so good?
Yeah, because when it was 40, they would have run out of screen.
Oh no. 0.000250 kiloliters. But we need to change that to what? Centiliters. So we're starting at K, right? And we're ending at C. See, you may be picking up, I said you could, once you get it, just write the number line once and you can visualize what you're gonna do. You just need to know where you're gonna start and where you're gonna end. So to go from kilo to centi, how many spots are they away from each other? 5, right? So if they're 5 spots away from each other, we also move our decimal 5 spots in the same direction. So it would be 5 spots to the right. And that means it's 25 significant figures. What should I do? How many significant figures? Is there?
3.
3. 25.0. Then make it centiliters. We keep 3 significant figures. All right, last one. 3,500 milliliters to deciliters. So this time, I'm gonna write using the same number line. Where's my start though? For milliliters.
M.
Little m. And where am I moving to?
D.
This is my end, right? How many spots am I moving to get there? 1, 2. 2 to the left. So we move our decimal here 2 to the same direction. And so our answer here is 35. And then to keep the significant figure, since there's 4, we would do 35.00. That's it. So metric system conversions, that's the first ones we're learning, are the easiest types of conversions. If you don't like or don't get this method, you can utilize what we do with all the rest of the conversions with metric. However, you would have to memorize every single one of these. Meaning you would have to memorize 1 kilo is like if it was 1 kiloliter, it's 1,000 liters. If it's 1 hectoliter, it's 100 liters, so on and so forth. So you could memorize all of these conversions because I'm telling you, I'm not giving them to you. These will not be given to you on a quiz or test. But what I am telling you is that you don't have to do it this way. You could just use this strategy and solve all your metric system questions that way. Yes. Yes, you may. All right, so that was conversion type number 1. Yes.
Take a picture of this.
Sure. Conversion type number 1 was metric system. Now, conversion type number 2 is incorporating the English system into the mix. And although you typically won't see English system assessed by Cambridge, what you do need to know is the technique that we use for it applies to when we're counting for atoms and molecules. When we get back to chemistry next class, the technique that we're going to use today is going to be applied for that. And so pay careful attention, and you are gonna flip over to the other side of your conversion paper. And we're gonna be utilizing other conversions that are not metric. So unit conversion, I will tell you in a moment. And so unit conversions, instead of writing equalities, a ratio of equivalent measurements can be written as a conversion factor. And so when we talk about equivalent measurements, we're talking about things, and they give you the example here, 1 meter equals 100 centimeters, but there's other equivalent units we've heard. Some of this you do in your head all the time, and you don't even really think about it too much. How many hours are in a day?
23.59.
Let's just say
That's the
24.
exact number.
You stay 24 hours, my bud.
It is, look it up.
One day. How many days are in a week?
7.
7 days, right? Oh, that could vary, right?
Could be 30 or 31.
Or 29 this month, right?
28.
28 in a general February. What about how many inches are in a foot? Do you know that?
No.
12 inches in a foot. That's one that most people know off the top of their head, right? So, if I asked you, just using one of these, I have 14 days. How many weeks have passed? How'd you do that? What'd you do in your head to come up with that? You divided 14 by a 7, right? To come up with 2. You used this as a conversion factor in your head. And so what you actually did when I asked 14 days is you did this. You said 7 days, 1 week, 14 divided by 7 equal 2. That's what you did in your head. You didn't write everything out. You showed it. You did it in your head.
And the days cancel out and the week is also 11.
Right, and that's what I talked about at the beginning of class. If something's the same on the top and the bottom, it cancels out, and that's what we call a unit conversion. So what we are covering today is something that it may seem abstract at its front, but it is actually something you do on a day-to-day basis that you don't even think about when you do it. And so what we're going to be doing is showing how we get there, especially for multi-step conversions. How do we get there? And so this paper that says conversion factors, right on the top of it, do not memorize. Right on the top of this paper, do not memorize. Given on quiz and test. If I give you something in the English system, because English system is not tested by Cambridge, it would be given to you on the test. So this side of the page, with all of these, it's like 20 conversion factors here. You do not have to memorize these. That's good news, right? You have to memorize metric, but I gave you a strategy for it. You do not have to memorize English. But what you will have to know how to do is how to convert. So we're going to be going over that method very shortly on how to use these as conversions. And so conversion factor, we call this a ratio of equivalent measurements. It always has something on the top and something on the bottom, and these two amounts are the same as each other. And so, for example, if I have 24 hours in one day, I could write that as 24 hours is 1 day. And now it's a conversion factor, we call it. And so the first thing to note is how to write an equality as a conversion factor. You're going to be looking for your equal sign. You put a dividing line there. So if you want to in your notes, you just write a slash there, a dividing line. One of the sides becomes the top of your factor. One of the sides becomes the bottom of your factor. And it can be flipped. So every equality has 2 potential conversion factors. If I have 454 grams equals 1 pound, it could be 454 grams over 1 pound, or it could be 1 pound over 454 grams. Where you have the equal sign is the division. Now, how do you know which one to use in a question? That's what we're going to learn how to do very shortly. But every equality can be written as 2 conversion factors. And so, as practice, on the next slide, you've got a couple to do yourself. You've got equality, write them as 2 conversion factors. Each inequality can be written as two conversion factors. Try this yourself before moving on. We'll solve it and then continue to the actual solving of questions using conversion factors. I'm gonna do this pretty quickly because we gotta get to what we need to use this for. So for the first one, we would write either 1,000 liters over what?
1 KL.
And the other option is
1 KL over 1,000 liters.
next one, 2.2 pounds over 1 kilogram. Or
1 kilogram over 2.2 over.
and then finally 12 inches, 1 foot, and 1 foot, 12 inches. I do want to tell you this now before moving on. Notice how here the words were written, but I used abbreviations. I will likely almost always be using abbreviations, and you need to be familiar with the abbreviations that are on this conversion factor chart. So if you aren't, I'm going to write the ones that you need to be familiar with now. OZ, what does that stand for?
Ounces.
Ounces. So if it says ounces in a question, you're looking for OZ. LB, what does that stand for? Ounce. You may want to write this down if you're not comfortable with these units. The next one is QT. Quarts. Gallon.
Gallons.
Gallons. The next one that might be confusing is PT. Pints. MI. Mile. YD. Yard.
Yards.
And I think that's the last one. I mean, FT and IN, what in inches? Feet in inches, yeah, which I already wrote here. If you don't already know these by heart, this is something you need to know by heart because notice how I printed it on the conversion factors paper. Their prefixes are being used. I typically use prefixes, not full words. And that's how most people in science communicate, just as a heads up. So you do need to be comfortable and familiar with the prefixes. So far, so good? All right, so now that we went over that, let's get to the strategy. This is what you're actually going to be following and using for the next several class periods. It has a fancy name, and some people absolutely hate this, but it is something that you do need to get practice with. It's an essential skill that you need to practice. It's called dimensional analysis. And so dimensional analysis, and usually I would have you write down the vocab, but you have it printed in your notes. It is literally a problem-solving method. All it is canceling units to figure out whether you multiply or divide by each conversion factor. That's what it is. To figure out whether you multiply or divide by each conversion factor. And so it is a reasoning skill. And we make use of the units in order to do this. And so what you see here is an example of a problem that's been done. That's 1,198 grams is how many kilograms? And so what they've done here is in the first part, this is your given amount. This right here is your conversion factor. And this right here is your final answer. And so we'll be deciding for each conversion factor whether we are dividing or multiplying by the numbers. And we're gonna be using the unit canceling to figure that out. So in this case, you would cancel out grams to become kilograms. Don't worry if you don't understand it on this slide. I have the method coming up, like how we're gonna create this from scratch on the next following slides. But this is just an example of what dimensional analysis looks like. And this is for our one-step question, but you'll be doing 2, 3, even 4-step conversion factors. For this skill, I'll be testing your knowledge of dimensional analysis. So on the quiz, yes. For multiple choice, doesn't matter. But if it's written out, yes. All right, continue. So how do you solve problems using this technique? So it is a technique of problem solving that you need to be familiar with. The first step is, in whatever question you're given, you're gonna need to figure out the conversion factors you're gonna need to use. How will you know? Well, you're gonna go to your paper, you're gonna look for the units you have, and you're gonna look for the units you want, and you're gonna make a pathway to see how to get there. So the first step is figuring out what you have, what you want, how do we get there? What's the conversion factors we need? Step 2 is make a pathway. So, for example, if I want to go from centimeters to miles, using the chart, you would have to go centimeters to inches, inches to feet, feet to miles. Every arrow here represents a conversion factor. And then finally, we're going to solve the question. And the formula you'll use is this. So this is something you do need to memorize for dimensional analysis. You will start by writing your given amount, whatever amount you have, with the units. And you divide that by 1. Then next to that, you multiply by each conversion factor. For the unit you want to cancel goes on the bottom, if the unit here is on the top, and the unit you desire goes on the top. Then you use whatever strategy you want math-wise. You can multiply everything across to the top, multiply everything across to the bottom, and then you come up with your final amount, the same way that I showed you in the warm-up exercise earlier. So that applies, the strategy applies here. So this is the steps. We're obviously gonna go over this from scratch, like how to do this. This is considered an essential skill in chemistry, just like drawing these structures, just like electron configurations. This is one of those essential skills, which is why it's gonna get a quiz, because it is one of those skills that you need to master. All right, continue. This is just how to solve. You don't have to write this out from scratch because I printed it out for you. The other thing I wanted to do was print out a solved question for you. So I solved the question for you, showing exactly how you go through this strategy. And so this question says 300 centimeters is equal to how many feet? And so looking at the question, you would first find your relevant conversions. Centimeters don't go to feet on your paper. You don't have a conversion here from centimeters to feet. You do have a conversion from centimeters to inches, and you have a conversion from inches to feet. You would have to use 2 conversion factors here. Your pathway, you're starting at centimeters, so you may want to write, you're starting here, that's where your given is, and you're ending at feet. You need 2 steps to get there. Centimeters to inches, inches to feet. You will need to use 2 conversion factors. And then you solve. And so in the solving, you would start with your given amount in the question that you're trying to convert out of, 300 centimeters. You write an invisible 1 under it. That's to help you with the math you're going to do. Then you place your conversion factors in such a way where you will cancel out the unit you have to get to the unit you want. So notice for 2.54 centimeters equals 1 inch, I put 2.54 centimeters on the bottom. And the reason we do that is so that we can cancel out the centimeters. And then in the next step, we cancel out the inches. And that gets us to feet as our final answer. And then for the math, you just multiply across the top, you multiply across the bottom. That's the strategy that most students are familiar highlighted it here, and then you divide those two numbers. with your answer. Why do I round here?
Because it's coming back to.
So yes, exactly. When I'm multiplying, the easy way to just remember is count the amount of significant figures in your original question, like whatever you're given. That's how many significant figures your answer should always be. So if this has 3 significant figures, which it does, then your end result will also round to 3 significant figures. So that's just to keep track of rounding, how do we round properly. That's why we spend a lot of time going over that at the very beginning of the year, so that it would come simpler now. All right. So that's a strategy, but it's already been printed for you here. Let's go ahead and go over it from scratch. Yes. The important thing is that we go over it from the beginning so you know what to do. Once you start feeling comfortable with the method, like I said, I've got a lot of questions here. You can start working ahead of me if you start feeling comfortable with the method and just verify that you're getting the right answers. But definitely for the first example, you should follow along to see how to do this. So first one, conversion factor practice, convert 150 liters into pints. So following the strategy, what's the first thing we should do? That's actually step 3. Right, you're skipping. The first thing is actually mental work. You should figure out what are you given, what are you being asked for, and what are the conversion factors we need to get there? How will we figure out the conversion factors we need? Do you have to memorize all of them? No, you just find them. You've got a paper here that's got the conversion factors that you need. Notice how this paper is broken into different columns. Volume, mass, length. Are we looking here, liters and pints, at volume, mass, or length? Liters. We drink liters. So is that volume, mass, or length? Volume, right?
Yeah.
So look at the column for volume. And so do you see anything with liters in that category that could eventually get us to pints? What do you think? I don't see anything directly from liters to pints, but do you see a path? Do you see liters going to something that does go to pints? Look at your chart carefully. So this is the thinking you're going to have to do.
Yeah.
You're going to need 0.946 liters equals 1 quart. That will turn you from liters to quarts. And then quarts turn to what? Quarts turn to pints. You have 1 quart equals 2 pints. So this already tells you you need a total of 2 conversion factors to make this happen. We're going from liters to pints. So this was step 1. Step 2 is your pathway. We're starting at liters. We're ending at pints. But do we have to go somewhere in between? Liters go to quarts. Quarts go to pints. So we're going to have to go liters to quarts and quarts to pints. We will have to use 2 conversion factors in this specific order. Now, before moving forward, step 1 and step 2, which I've outlined here, in the future, can be done in your head. Like, you do not have to show me, you know, the conversion factors because you'll have this paper in front of you. So you'll be able to pull the conversion factors as needed. So as Jose Enrique did actually, you could, once you have your pathway, you could go to step 3. The part you have to show me is the canceling app, that you know how to cancel correctly. So the part you have to write down for the quiz, for example, the written part of the quiz, will be step 3, which is the actual active dimensional analysis, the actual math you have to show. And so step 3 is to start by writing your given, which is 150 liters. And what number do I put under that? 1. And so that's following this. Just to go back real quick, we always start with this, our given amount over 1. Now, I never write the 1, I just know it's there. But if you don't know it's there and you don't like know how to interpret it without it, this is like training wheels. Writing the 1 there to help you with the math. Then we write our first conversion factor. Our first conversion factor is from liters to quarts. Now this is the most important part. If you don't get this, this is going to hurt because it's the whole strategy is right here. We have a conversion, 0.946 liters equals 1 quart. What goes on the top and what goes on the bottom? Quarts should go on the top. And if you want to write it out the same way so that you understand that it's canceling, you could write out the word liters. And liters go on the bottom. Why? Why? Why is it quarts on the top and liters on the bottom? Alberto.
Why can't you just say, 0.946 liters equals 2 pints, just straight up? The equation, why can't I just put pints?
You can. Because you did 1 over 1 in your head. And that is, Alberto, that's an excellent strategy. That's going to benefit you in next class's lesson. Because you can actually take a 2-step mole conversion when we get to the chemistry part and turn it into 1 exactly the method you just said. So the answer to your question is yes, you can. If it happens to be 1 over 1, yeah, that would happen. You could make that equality. You can do that. I'm okay with that. You could turn that into a 1-step question. As long as you show what's canceling. I'm good with it. Cambridge would be good with it too. But do we understand why the liters go on the bottom here? And it's because whatever you start with, that part of the conversion factor has to go on the bottom so that it cancels. It's that whole canceling technique. The same thing on the top and the bottom, cancel out. Now, given that we're just following the strategy, we would move on to our second conversion factor, which is 1 quart and 2 pints. So our second conversion factor is, do quarts go on the top or quarts go on the bottom? They do, because they have to cancel again. And then 2 pints go on the top. And then the quarts cancel. Alberto's absolutely correct because this is the 1 and the 1 that cancels, so you could have just like gotten rid of that whole thing. Sure, that works. And then we do the math. What's the math?
Top times bottom.
So 150 times 2, or 150 times 1 times 2, which is 300. And then on the bottom, it would be 1 times 0.946 times 1, which is 0.946. Then you have to write the unit. What's left? What did cancel? Pints, right? Now divide the numbers. And I'm going to write here, you should. It's 300 divided by 0.946. You should write this down. This is the order you have to divide the numbers. The reason why I'm stressing this, and I'm stressing it, is because in the past, including last year and years I've taught at CAE, I can tell you about 20% of students will divide these 2 numbers wrong and come up with all wrong answers on their quiz and get a 0%. Just for that. This number goes first, this number goes second when you're dividing. You think, no, it won't be me. It could be. Be careful. Write it down. All right. I get 317.1247357. Does anybody want to hear all those numbers? Or are we rounded? Where are we rounded to? How many significant figures? The given, right? So it's 2, because there's no decimal. So that's rounded. So this would be 320. 320 times. If you gave me 317, you'd get most of the credit. But for the absolutely correct answer, rounded correctly is 320. 2 significant figures. All right, how do you feel about it? We're okay kind of so far? Doing all right? Ready to see another one? In the other classes, I was able to get through 4 examples. This was 1. So we're going to do 1 more of the standard type, and then we're going to look at a couple of unique scenarios before we go. How many of you remember doing this in another class? Raise your hand if you remember doing this before. That is This is a 30 student class, just so you're aware. I'm just getting an idea. It helps me as a teacher to know like pacing. If you aren't familiar with it, you don't remember doing it, it's okay. It's just that means you've got some work to do, right? So let's try again. 14.6 grams to ton. What's the first thing we should do before we do anything else?
Find out how.
We gotta figure out what we have and what we're being asked for. Now that looks silly in a question like this where it's easy to point it out, but you're gonna have word problems too. And so you do have to identify what is your given and what is your asked for. What are they asking for? They're asking you to change grams to tons. And so the next thing you need to find is what are the conversion factors that will get you there. Do you have to write this down in the future? Like if you're taking a quiz, do I need you to write down the conversion factors before you start the process? No. I'm writing it down because I'm showing you the train of thought. But only step 3 has to be shown. So grams to tons, where should I be looking? Volume, mass, or length? Grams to tons. Mass, right? So in mass, I see 453.6 grams. That's grams, so I'm starting there. Is a pound. Pounds aren't tons, so what could I do now? I would do 2,000 pounds equals 1 ton, right? That's the other one I need. So this is another 2-step question. We're gonna have to do 2 conversions. One where we switch grams to pounds, and one where we switch pounds to tons. And you can write it all as one line. That's the really powerful thing about dimensional analysis, is you just do one set of multiplications and divisions.
Where did you get 2,000?
1 ton equal 2,000 pounds.
Oh, yeah.
It's the second one. I just wrote it backwards. It's the same thing though. It's an equality. So then, half. This is just to keep track of what we're doing. We're gonna go from grams to pounds, and then pounds to tons. That's our pathway. Remember, step 1 and step 2 do not have to be written down. You can do that in your head if you feel like. If you're comfortable doing it in your head, I'm okay with you doing that part in your head. If you prefer to write it down, that's fine too. Step 1, step 2. What you have to show me is the actual, what are you multiplying and what are you dividing and what are you canceling to get there. And so for step 3, what do I start with?
You put the 14.6 grams.
I'm gonna write the abbreviation, 14.6G over 1. Now what?
Times.
Multiply by conversion factor 1, right? Conversion factor 1, we need to get rid of grams. So 453.6 grams equals 1 pound. What do we put on the top? What do we put on the bottom?
We put LB on the top.
And we put the grams, which is a really important thing to know. Let this inform you. The grams have to cancel. So the part that goes with grams has to go on the bottom, and the pounds has to go on the top. That's so this cancels, so we know we've converted from grams to pounds. It also tells us, if you're comfortable with it, that this is just a division. 14.6 divided by 453.6 divided by those 2 numbers, I'll have pounds. And that's what you're going to do. Your resource that you don't have to memorize, right? You go to the math column and you look for those. This is what you're gonna have for the quiz and the test. That this is what's given, you have to memorize metric system only. So one side you have to memorize, the other side is given. All right, so far we got the first one done. Now we need to go pounds to tons. How many pounds for how many tons? And what goes on the bottom? We need to cancel out pounds.
Ton goes to the top and LB goes to the bottom.
We need to cancel out pounds, but pounds goes to the bottom and ton goes to the top. And now we do the math. The math is 14.6 times 1 times 1, which is 14.6 for the top. On the bottom, you do 453.6 times 2,000, which is 907, 200. And then you divide those 2 numbers. It's 14, and yes, it will be a really small answer. Divided by 907, 200.
I got 6.
Depending,
1.609.
depending on the calculator you are using, you may come up with one of two answers. Both answers are correct. So I'm going to tell you what they are, both of them. You could have either came up with 1.61 times 10 to the negative 5 or e to the negative 5. Or you may have a calculator that gives you standard form. Standard form would be 0.00000161 times. I accept both. Like if you give me the version in scientific notation or you give me the version in standard form, I accept both up to a point. And we'll talk about that point next class. Because we'll be looking at 23 zeros next class, which we're not going to write. Always
I
remember
got
that.
some theories in the first one, but it's just not.
They use 454 instead of 453.6.
Which answer would this one give? Potassium.
I don't know.
All calcium.
Did you try it though?
Oh no, it's just
You gotta try it. Not sure, you have to show me. But either of these two are acceptable.
I got this as well.
Yeah.
No,
You're
but
good.
not the correct answer.
You got a different answer?
Yeah, it's similar to the first one.
That is the same thing. You just have to interpret that as negative 0.5 is 10 to the negative 0.5. That's the same thing. You have to fill in the rest though. You can't write 1.61 negative 5 as an answer. If that makes sense.
Yeah.
Because that's not the same thing as that. That calculator no bueno. This is the way you should write the answer. So you need to interpret if your calculator says this, it's this.
Yeah, because
You gotta fill in the exponent, the 10 to the negative 5. Yep. All right, that was example 2. I told you we got through 4, so we've got 2 more to do. There's more than that on the slide. If you want to do more, you can, but there's 2 more we need to do to go over the different strategies. So let's go ahead and go over the next one. Are we good to move? Yes. You need a little bit of time? Yes, you may. So there's 2 more scenarios we need to look at. One is how do we use given information in a question as a conversion, and the other one is called double conversion factors. And so we'll be looking at these last 2 scenarios before we go for the day. Ready? All right, this is the next one. Using given information as a conversion. And so let's follow this strategy. There's something a little bit different here in terms of what you need to do to convert. It's a word problem, first of all. Second of all, it's something that you've seen before, technically. Because we learned density earlier, like in unit 1, we went over density. So it says, what is the volume in liters? That's my question. That's what I'm being asked for. But you should annotate the question. What am I being asked for? What am I being given? That was one of the reasons that I printed out the notes for you so that you could annotate the questions instead of spending time just writing them down. We're looking for the volume in liters of a pure silver coin that has a mass of 14 grams. You should underline any relevant numbers. 14 grams is a given. They also tell you the density of silver, which is a given. So we're given 14 grams. What else are we given?
The bottom.
We're asked for the volume
10.5 grams.
per milliliter. How would we write that as a conversion factor? That is a conversion factor, isn't it? G/ml? 10.5 G divided by milliliters. What would be the number that goes with milliliters? These are important questions that end up being sources of confusion if you're not careful about it. If you see G/ml, that's always 1 per 1 milliliter. So there's an invisible 1 there. And so this is actually a conversion. Hidden conversion in the question. So instead of memorizing formulas formulas for density. And there's actually a ton of other formulas that you could just straight up memorize. If you understand dimensional analysis, you don't have to memorize any of those formulas because they all follow the same strategy. I didn't teach it back when we learned density because we were only doing that back then. But now that we're going to be looking at the rest of the math, if you know the strategy, it just carries through. It makes some things much easier because you don't have to memorize a series of formulas. You just know this one strategy and it always works. So we've got a conversion here. Can we use this conversion?
No.
We've got grams.
If you look at
We have to flip it, right? So we could actually move straight to step 3. Step 3, because we've got the conversion, we've got the given. Start with your 14 grams. Because you don't start with your conversion, you always start with your single number. 14 grams, that's what we want to change up.
So we want to do 25.
Correct. So we start with this 14 grams over 1, and then we multiply by our conversion factor. What we want to get rid of is grams. So instead of how the conversion factor was presented to you, you just have to flip it the other direction, which is why it's important that I rewrote it like this. So we would write 10.5 grams on the
Top.
and 1 milliliter on the
Top.
top. Do 14 times 1, the grams cancel. Do 1 times 10.5, and what does that give you so far?
14 over 10.5
Which is,
divided and
I get 1.3333333333.
and you want to reach.
We only write 2 numbers, right? So 1.3 ml. Are we done?
Yes.
Are we done?
No.
What is it asking for?
The
Oh.
density is over.
Oh,
The
well,
volume.
What is the volume in liters? What is our current unit when we did that conversion? How do we go from milliliters to liters? If you remember. Now we go back to this, right? King, Henry, Vance. I'm usually drinking chocolate milk. I want to change from milliliters to liters. Liters is the base unit. So now I need to move my decimal over how many spots? 3 to the left. So you do that here. 1, 2, 3. 0.0013 liters is your answer.
Then you
From start is at milli, N is at base unit. Because it's one letter. Liters is a base unit. So it's 3. You have to move. And that's it. That does it. So you may recall that you had a formula for density. Density is mass over volume. And if you didn't memorize it that way, you may recall you had a triangle for density. You may remember it as a DMV. 14 divided by 10.5 is taking the mass and dividing by the density to get the volume. Literally the same thing, using a completely different strategy. So what I'm trying to tell you is that if you know this strategy, you don't have to memorize a bunch of triangles and where letters are placed and a bunch of formulas because the strategy will actually always work. And so that's why it's so important that you get it down. All right, so that was our third example. We're going to step it up one more notch. Go ahead. Last example. One more notch. So you're going to see me skip a couple slides. I actually sometimes do that, or a lot of times I do that in lessons. I just don't have it pre-printed for you. This time you're going to see me skip a bunch of slides. And we're going to do something called double. So you're going to want to write at the top of this, double conversion factors. Your last 2 questions in the homework are like this. So we need to address it. Double conversion factors. What do I mean by that? Look at this. This says convert ounces over feet to pounds over miles. So, step 1 would be to identify what's your given and what's your asked for. I would rewrite it as 5 ounces, which I'm gonna write over how many feet? If there's no number, do you remember what I just said? It's 1. This is to help you work out the math. That's why you see me rewriting it. And what am I changing this to? I'm asked for how many pounds for how many miles, right? So this is going to be more work because we've got to change ounces to pounds, and we've also got to change feet to miles. So let's find our conversions. Let's find the conversions for this. How would I know how to go from ounces to pounds? What do I look at here? Ounces to pounds. Do I have something for that on your paper? Ounces to pounds. Somebody shout out if you find it. 1 pound equals 16 ounces. And that's it for that one, right? That'll get us between ounces and pounds. What about feet to miles? Do we have something from feet to miles? 50 to 80, or let's do it this way. 1 mile, that's the way it reads out, is 50 to 80 feet. We've got these two conversions. And so now we just have to know how we place them. So now we're going to go to our step 3. Start with your given. 5 ounces over 1 foot. In my experience, this is where people get stuck, like right here. Like, where do I go from here? The suggestion is to do one part first, like the top part first, and then do the bottom part as a second conversion factor. So how do we change ounces to pounds? How would we put the conversion factor in here to change ounces to pounds?
1 by 16.
Right. This is the conversion factor to get you from ounces to pounds. So you've got to cancel out the OZ. That's the most important thing you've got to understand here. So the 16 has to go on the bottom, which means division. And the 1 pound has to go on the top. Has to be like that. That's our first step. Are we done?
No.
No, we still have to change feet to miles. And so we take a second conversion for that. Right side one. This is what makes this a unique question. We need to change feet to miles. But how can we cancel out feet? Feet is on the bottom. So how would I put this conversion factor in here?
5,280 feet.
Right. So that's the skill. Is to recognize, well, if feet are on the bottom, then on the conversion factor here, they have to be on the top. And we cancel that. And this becomes 1 mile. Feet cancel. And the only units you have in the end that didn't cancel are the units you're looking for in your final answer, so you know it's done correctly. Then you just have to work out the math. 5 times 5280 for the top. 5 times 1 times 5280. I get 26,400. And then on the bottom, 16. And that's pounds over mile. Can we simplify that more?
Yeah.
Should we simplify that more? Or does it make sense to communicate to someone 26,416? Simplify it more. So you divide 26,400 by
You get
16 is 1650 pounds over miles. And that's your final answer. All right. Yes.
Do the Cambridge examiners get picky about simplification?
No. No. And we're good with significant figures. So this is good. All right, so that is the first lesson on this unit in math. We will be returning to chemistry topics next class because we'll be learning how to calculate atoms. We'll be learning how to work with grams and amounts of atoms. But you'll need this strategy for next class. So you've got homework, and the first 30 minutes of next class, as always, will be a bell word for you to practice what you learned here, so that you can be successful as we move forward. I hope printing the notes helped out with being able to follow along. I'm gonna go ahead and give you the homework now. If you want to get started on it, you can. If you need a brain break for the last minutes of class, you can also take a brain break for the last minute of class.
That sounds so good.
No, it's like a level chemistry thing, so again, like, how'd that get here? Definitely not something that you need. Third year chemistry. Here you go.
Oh.
Good morning, CIE. This is Destiny. Giuliani. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. And now, a moment of silence. You may now be seated. Hear your morning.